So the first speaker is Pauliina Damdimopoulou, living in Stockholm and working in Karolinska University. If you don't know, this institute is the institute that provides the Nobel Prize on Medicine, awards the Nobel Prize. I first heard the Pauline's presentation in Copenhagen on EDC, influence on women health, and I was keen on inviting her to our event. And we are very lucky that all our speakers agreed to participate in our webinar, and I'm going to present Pauliina more scrutinized. She's a professor of reproductive biology, and she's also head of biological endocrinology, and she's also the head of Pauliina, the floor is yours, and you can share the presentation. And let me remind you that you will receive all the presentations after our event.
Pauliina, thank you. You can share your presentation and start.
Thank you. Thank you so very much. Let me see. And then I have to change the settings. Do you see my screen now?
Perfect. Yes.
So thank you so much for having me here today. I get invitations to give webinars often, but I never imagined that I would get the request from Ukraine. The news that I see from Ukraine on TV every day made it very difficult for me to understand that you would have the capacity to even think of the environment and plastics and chemical pollution. And I met with the Zero Waste Society representatives, and we discussed how important it is to take care of the public health and the environment, even in times of crisis. So here I am. I will be talking to you about plastics, chemicals, and female fertility. It is really a true honor to be giving this webinar to you, and I can only hope that you will find it meaningful. So I'm Pauliina Damdimopoulou. I'm professor of reproductive biology at Karolinska Institute, and I have been leading a research group called Chemicals and Female Fertility for 10 years. And I want to start by acknowledging all the members of my team, the funding that we have, and the collaborators that have made it possible to study this topic. So this presentation is about plastics and chemicals, and we will start with the statistics here that shows you the growth of the global plastics production and chemical industries since 1950s. This is when the industry promised us better things for better living through chemistry, and they have really delivered their promises. And it is important to understand that this is a continuous growth. We are at this point on the graph marked, and the production volumes and numbers are increasing every year. And really the chemical innovations and new materials like plastics have transformed our lives. It is difficult to imagine how it would be without all these innovations. Plastics and chemicals are found in our cars, in our electronics. They enable food production, of course, cosmetics, personal care products, pharmaceuticals, textiles, and plastics in all forms. And plastics, it's been estimated that there's at least 16,000 chemicals being used in the manufacture of different types of plastics. And this is really how it goes. Plastics is always connected to chemicals. Plastics is made of polymers, but the polymers alone do not make good plastics. You always need chemical additives that give the properties to the product. They could give a color, they could be biocides, they could be processing aids, fillers, many different functions. And plastics, of course, we often think of packaging, but plastic materials are used in so many more sectors of the society. The 5 largest sectors are the packaging industries, construction industry, transportation, textiles, and different consumer products. And as I mentioned, there's a lot of chemicals being used in the making of the plastics, over 9 billion tons annually. And they have different functions. They could be different types of organic chemicals, inorganic chemicals, and also a big part of the chemicals used in the plastics are unknown. We don't really have much information about them because there is very little transparency in how chemicals are used in plastics. And this is not all the problems with plastics. The bigger problem is also that plastics and the chemicals are derived from fossil carbon, from fossil fuels. And it has been estimated that 90% of the petrochemical industry output goes to making plastics. And these numbers are growing, as you remember. So the more plastics we use, the more we also contribute to climate change, for example. And the recycling of a plastic is a real problem. Half of the plastics we have will be landfilled, 19% burned, only 10% recycled, and the rest is dumped into the environment, where it will degrade into micro and nanoplastics and also release a lot of the chemicals to the environment. And this we can see a lot in the news these days. Different chemicals, for example, the PFAS, forever chemicals, are detected in global rainwater at levels exceeding what would be safe for drinking water. These same PFAS chemicals end up in our food, for example, eggs. Plastic particles themselves have been detected in many different parts of the human body, like in the brains. And then, of course, plastic-related chemicals are found in many consumer products. Here is just a recent news saying that bisphenol A has been found in baby soothers. So we produce a lot of plastics and chemicals, and they end up in the environment and our bodies. But is this a problem? The problem really is that we have not been able to test the safety of chemicals to human health and to environment. We don't actually even know how many chemicals we have on the market. Depending on the report, it could be 100,000 or even 350,000. And it is because we don't have good inventories of chemicals. Within the European Union, we have a very extensive chemical legislation and also a strong ambition to have safe chemicals in the future. Yet the starting point is this iceberg. 70% of the chemicals on our market have been poorly characterized. And even the well-characterized chemicals, the 500 that are on the tip of this iceberg, it is fair to ask if we really covered all relevant testing endpoints when we have tested their safety. And of course, this topic now today is human reproduction and fertility. So are we covering everything to be sure that chemicals are safe? And this topic, I think, is increasing in interest because we know that the birth rates are declining globally. For a population to remain stable, every woman should have, on average, 2.1 children. And in many parts of the world, we are below this number. For example, the US and Europe have been below this replacement rate for the past 5 decades. And actually, Ukraine has had the lowest birth rates in Europe for many years. And the big question is, why are the fertility rates declining? And this is very multifactorial. And of course, the decisions of people to have less children is a big part of this. And we need another type of statistics as well to understand what might be behind these figures. Could it be infertility? And we actually know that the use of medically assisted reproduction in fertility treatments is increasing. So first of all, infertility, the definition is that a couple is trying to conceive for a year without succeeding. Then the diagnosis infertility can be given. And there's at least 10 million assisted reproductive technology babies born since the first IVF baby. And also these businesses are growing every year, 5 to 10%, both in terms of treatment cycles and the money in the business. And as I mentioned, Ukraine has the lowest fertility rates in Europe. I was not able to find statistics on the infertility treatments. But for example, in Northern Europe, there are already, like Finland, where I come from, 7% of all newborn babies are due to assisted reproductive technologies. So at least one child in every classroom is due to these treatments. And although the treatments are available and used a lot, not everyone is getting the help they need, and 1/3 will remain childless. So here the question comes, these people who would really like to get a child and don't succeed, could there be a role of the environment as well? And this topic has actually been discussed since 1990s, when it was first discovered that male fertility, male sperm counts are declining. And this topic has been now researched very well over the years, and it has become established that certain types of environmental chemicals like phthalates can reduce androgens in males during fetal development, leading to reduced fertility later in life. And actually, when we test the chemical toxicity to reproduction, this is one of the endpoints used in animal studies: male fertility, male sperm counts, and male reproductive tract development. And for example, phthalates are regulated in EU based on male reproductive toxicity. Now, of course, compared to men who can make 1,000 new sperms every second and remain fertile, females have much more limited fertility. The most fertile woman makes 1 egg a month, and their fertility ends midlife in menopause. And actually, we are not very good at measuring female relevant reproductive toxicity endpoints in the animal experiments. And we therefore don't really have enough data for risk assessment related to female fertility. And consequently, I'm not familiar with any chemical that would be regulated based on female fertility endpoints. So a lot of my research has focused on understanding the role of chemical pollution in female fertility and reproductive health. And we will look into some of my data. So I mentioned there's hundreds of thousands of chemicals, and it is important to know that there is no method that can measure all these chemicals at once. If you ever want to measure chemicals in patient samples or any kind of sample, it is good to decide beforehand what you want to measure. When I started my studies in Sweden, I decided to focus on well-known chemical contaminants that are suspected toxic chemicals or known toxic chemicals. The first group I focused on is persistent organic pollutants that contain the famous pesticide DDT that even got the Nobel Prize in Physiology or Medicine from Karolinska Institute. And these persistent chemicals are so toxic that they have been internationally restricted. The second group I have been looking at are the PFAS chemicals, also known as the forever chemicals. And there's thousands of them. Only a couple of them has been restricted recently, but many remain in use. And I measured 8 of them in my studies. They were taken to the market in the 40s, 50s, for example, through non-sticky frying pans. And these 2 first groups of chemicals are very persistent in our bodies and in the environment. The last group of chemicals contains bisphenols and parabens and phthalates. These are typically used as additives in plastics and consumer products and personal care products. And to my knowledge, there is no international restrictions. And these chemicals are very quickly metabolized from the body. So I started by measuring these chemicals in 185 women going through assisted reproductive technology. We measured the levels of chemicals in their ovaries where the eggs are maturing. And here you can see the results. The size of the dot tells you how many of the women had the chemical in their ovary, and the color tells you how much of it. So the persistent organic pollutants that have been banned in Sweden since 1970s are still detectable in all the women because these chemicals are very persistent in the environment and in our bodies. The PFAS chemicals haven't really been regulated well yet, so we could find them even more commonly in all the samples and in higher concentrations. And the bottom row are these phthalates and parabens and bisphenols that are excreted very quickly from the body, but we are constantly exposed through our lifestyles. So we were actually able to find phthalates and parabens in every single ovary. So the take-home message is that human eggs are growing and maturing in an environment that is full of human-made chemicals known to be problematic. And now it's of course important to know if, one more thing. Of course, the women still get pregnant and they will have a fetus growing in their wombs. And these chemicals actually follow and expose the fetus as well during fetal development. So here you can see the levels of the persistent chemicals in human fetal tissues from trimester 3 intrauterine fetal death cases. And for example, the fetal adipose tissue in this case has a lot more of these persistent chemicals than we would ever guess if we looked at the maternal blood samples or the placenta samples. So we are truly exposed through our lives, from the egg to the fetus, and then of course, postnatal life. So the big question is there a consequence for our health? And in my studies, we have focused a lot on ovaries and fertility in these women. And we have found that women who have higher level of exposure to the persistent chemicals have less immature eggs left in their ovaries. The women also have a disrupted growth of these oocytes or the follicles to ovulation, and there's a reduced quality of the embryos. And these altogether lead to longer time to pregnancy and higher odds of being diagnosed infertile. And these results are not very shocking. They have been confirmed in many international studies, and consequently, the medical society is now paying more and more attention to environmental factors when they are discussing female reproductive health. And here's just some examples from clinical societies and recent reviews focusing on the question of environmental chemicals and female fertility. And altogether, the contamination has been linked, for example, to disrupted puberty development, irregular cycles, polycystic ovaries, endometriosis, uterine fibroids, infertility, and early menopause. There is a lot more to discuss about the environment and reproductive health in humans, and I invite you to look at these fact sheets that were developed by the European Society of Human Reproduction and Embryology last year. They summarize climate change, air pollution, chemicals, and their effects on male and female fertility and the offspring health as well. And they're very informative and could be even given to patients or your friends or whoever. They are freely available online. So we talked a lot about chemicals, but what do we know about the plastics actually? I mentioned that, of course, most of the plastics ends up in the environment. It will break down into micro and nanoplastics, and this topic is being discussed a lot recently. I was invited to write a review on the topic, and that was actually, I think, came online yesterday. So in this review, we went over all the literature past 10 years relating to microplastics, nanoplastics, reproduction, and fertility. And altogether, we found only 40 papers. 10 of them were focused on humans and 30 on animals. And these animal studies covered 14 different species. And for example, this is a graph showing to you when microplastics have been detected in different human organs. So you can see that most of these studies are really recent. The past 4 years, we've had more and more evidence coming out that microplastics are found in different organs. However, it is very difficult to compare the exposure levels because we do not have good methods to measure microplastics. So every group uses their own way, more or less, and the results tend to be very different. And the cohorts are also small. So it has been very difficult to do epidemiology or statistics linking the exposure to health. And on the top of that, of course, we have so many different types of microplastics. There are many different types of plastics with different chemicals in them. And obviously, that's why our exposures are also to many different kinds of plastics. Here, for example, you see different plastic polymers that have been detected, for example, in semen samples in men or in endometrium in women. So this is a very complex topic, and there hasn't been big studies yet with reliable methods. There's been many animal studies done, as I mentioned, and altogether, these animal studies suggest that if you expose to microplastics in high enough concentrations, you will end up having problems, usually increased oxidative stress and inflammation, and also mitochondrial dysfunction. And then this has been linked in the animal studies to ovarian function disruption and reduced oocyte quality and embryo development. And on the male side, worse sperm quality endpoints. So it is fair to assume that microplastics exposure is not very good for reproductive health, but we are still not really able to connect the dots from the level of exposure in humans to the health outcomes. So if you think of the state of the science when it comes to chemicals and plastics, I could say the following. Human-made chemicals were introduced to the market in 1950s, as I showed in the first picture. And already the same decade, it was clear that uncontrolled use of these pesticides like DDT lead to environmental damage. And this is when the first environmental protection agencies were started and the regulations, the work to get regulations in place and testing was initiated, and a lot of research. So as a consequence, we have 70 years of research data on different chemicals and health outcomes in the environment and in humans. As an example, if I look at the term phthalates and reproduction, I get over 4,000 research articles on PubMed, and most of them are original research. So as a consequence of this long work on chemicals and human health, we have chemical agencies, there is testing requirements, risk assessments, analytical chemistry methods to measure different chemicals, biomonitoring programs, we know levels of chemicals in different populations, and even some international regulations, although I would of course like to see much more. And we can quite fairly say now that exposures to chemicals are not good for fertility. They are linked to negative effects both in females and males and also in the offspring, which will be covered in the next talk. When it comes to plastics, the awareness is increasing a lot now, and there's a lot of popular science news on the detection of microplastics in, for example, brains and testes and ovaries. However, the research is still very limited. If I look into microplastics and reproduction in PubMed, I get merely 300 papers, and a lot of them are reviews. So we discuss this topic much more than we have done research on, and I really hope that this will change and we get more and more research. But as a consequence, there's no clear testing requirements for plastics, no inventories of what kind of plastics we have. We don't have analytical methods to measure them, no biomonitoring, and no international regulations. There's been very intense attempts to establish global plastics treaty that would control how we produce plastics and take care of the waste, and all efforts have unfortunately failed so far. So state of the science, we know much more about the chemicals than we know about the plastics. However, we really need to research plastics much more. So what can we do with the situation at hand? And I think I can recommend 3 different levels of action. First of all, it is important to try to reduce the environmental contamination as much as we can. So recycling is important to prevent plastics and chemicals from entering the environment, and also altogether reduced consumption will of course lead to reduced waste as well. When it comes to human exposures, of course we can avoid using plastics as much as we can, especially when heating food, and there's also data showing that ultra-processed foods have more chemical and plastic contamination than other foods. And personal care products and cosmetics is a source of many of these chemicals I was discussing, so reducing the use of those will help to some extent with personal exposures. Also, cleaning and ventilating your homes can improve the indoor air by removing the dust where many of these chemicals and microplastics end up. But this will not be enough if we don't get the systemic change as well. So I think as consumers, we can steer the market with our choices. If we buy less and we choose more wisely what we buy, this will eventually lead to the industries responding to that consumption. And then I find it very important to be an educator and advocator about these topics that are not always on the top of the political agendas in different countries. And when we get to votes, I think it would be very good to try to help those decision makers in power who care about the environment and want to make a systemic change to really truly protect human health and environmental health. I thank you so much for listening.
Thank you so much, Пауліна. Дуже дякуємо Пауліні за виступ. І хочу також сказати, що
Thank you, Pauliina, for your presentation. And also I would like to say that I enjoyed the last slide, what we can do. Because once we hear a very shocking information, the one we never heard before, so sometimes you feel in despair, but when you understand that there is something that can be done, it can make you do something. And also there are 3 levels. What can we do? How we can decrease the level of consumption by working with our close people, with our friends, acquaintances, families. So it's very good to know what we can do.